Okay, good afternoon, all. Today we are going to see about going to see about the one more concept and function that is called recursive function. So we'll see what are the different parts of recursive function and the types of recursive functions and what are the pros and cons. So recursive function is just a function which call itself again and again is termed as recursive function. That is, till now we have written one function and we will call that function. That's all. Now within that function itself, we are going to call the same function. So that concept is called recursive functions. So there are some certain problems which are recursive in nature. So in that case, we can go for the recursive function. So the same function is called recursive. And so when the problem is solved using your source code will look okay somewhat it will be means your code will the number of lines of code will reduce function. Okay, sorry, due to some network problem, I got disconnected. Okay. Is it audible now?
Yes, ma'am.
Okay, thank you. Okay, so recursive function is just a function which is going to call the same function. So there are some two parts in recursive function. So one is called the base part. Because a function, if a function is calling again the same function, there might be a chance it will keep on executing, and if there is no terminating condition, it will keep on executing and it will result in some memory error. So we have to write a base condition for the recursive function to get terminated. So to be mentioned for the termination of the recursive call, and the next part is the normal recursive part. So this recursive part is going to call the same function. So these two parts are necessary for the recursive functions. So this is just going to invoke that recursive function. And there are some different types of recursive function. So one is direct recursive function, that is the same function is calling itself again and again. So for example, suppose if we have one function called sum. So inside sum, so inside this function itself, maybe we'll have some set of statements, so maybe base part, and within that itself we will call the same function. So this is called direct recursive functions. Indirect recursive function means one function will invoke another function. That is, function 1 will invoke function 2, and function 2 will invoke the function 1. So two functions are involved in this. So for example, so we will have one function like maybe sum. So within that function, maybe we have another function called product. So we are calling that particular function here, and similarly we have one more function called that product. Within this function, we are going to call the function sum. So this is called indirect recursive function. So sum is calling the product and the product is calling the sum. So these are different types. So next one, we'll see what is recursive. So simple example is the factorial of a number. So suppose if you want to find the factorial of number 5. So factorial means 5 into that number, 5 into 4 into 5 factorial can be written as 5 into 4 into 3 into 2 into and 1. So in that, we can write the 5 factorial as 5 into 4 factorial. Okay, so here 5, and again this actually represents 4 factorial. So we can write the 5 factorial as 5 into, so if we found the factorial of n minus 1, we can suppose this is equal to n. So if we found the factorial of n minus 1, then we can simply find the factorial of n. Similarly, 4 factorial can be written as 4 into 3 factorial. So using the factorial of previous number, we can find it. Similarly, this 3 factorial can be written as 3 into 2 factorial. And this 2 factorial can be written as 2 into 1 factorial. And finally, for finding the 1 factorial, we no need to go for any previous factorial. We can simply return the 1. 1 factorial is 1 only. So that is the base condition. So here only our recursive function stops. Till that, if for any n, how we can find the factorial means, we can find it using the formula n factorial is equal to n into That is 5 factorial is equal to 5 into 4 factorial. So n factorial is equal to n into n minus 1 factorial. So we can for finding the factorial of 4, we can again call the same function, but only with the different n value. So for finding the factorial of 5, we need 4, and finding factorial of 4, we need 3, and we need for finding the factorial of 3, we need 2, and finally 1. So factorial of 1 is 1. We no need to do any further calculations. We can directly return the value as 1. So this is how we are going to define the recursive function for this factorial problem. So now we'll just write the program for this. Okay, so now we are going to write the function, factorial function. So the input is, we have to find the factorial of one number. So only n is the input to this function or argument of this function. And then in recursive function, usually we will have some two parts. So base part and recursive part. So first base part. So at what condition we are going to terminate? So the terminating condition is, for finding factorial of 1, we no need to call the function again. Instead of that, we can directly give the value. So if the value n is equal to 1, then we can directly return 1. So this is our base part. And our recursive part is else. If it is other than 1 means or greater than 1 means, we can go for the else part, that is recursive part. So in that recursive part also, we can write return. So factorial of, for finding the factorial of n, we are going to use the formula n into and factorial of n minus 1. That's all. So we are calling the same function inside the another function. And then finally we can call this function using outside this function. So suppose I want to find the factorial of 5 means, we can just call it like this. So here this function is returning the final value. So we have to either get the value in some variable, or we have to directly print the value. So here I am just directly I am going to print the factorial of 5. So whatever is returned by this function will be printed directly. Factorial dot py. On running the program, so we'll get the output as 120. Suppose if I forgot to write my that base part or the terminating condition of the recursive function, we'll see what happens. Okay, so instead of this, I am simply going to call only the in my program only recursive part is there, but I have I didn't write that base part. Now we'll see what is happening. So see, recursion error. So maximum recursion depth exceeded. Okay, so again and again the function is recursively get invoked. So here the previous line repeated some 990 more times. So this statement got executed for this many time, and there are some maximum limit. Then after that it is showing error. Okay, so that's why we have to be very careful while we are writing using recursive function. We have to make sure that we have written the base part. So actually how this will happen means, usually during a function call, all the function informations will be stored in a stack. So while during this function call factorial 5, after the execution of this function, where it has to return the value, so that information will be stored in the stack only. So here this stack will have factorial of 5, and similarly after that within this factorial of 5 again it will call factorial of 4. So that information will be again stored in stack. Stack means it's something similar to the list, but having some restriction, like in a stack there will be only one opening. Okay, so we can insert here only and we can delete from here only. So only the top element can be deleted and only we can insert in the top only. We cannot, suppose if there are any entries above this, means we cannot touch this factorial of 5. So that is meant by stack. But in list usually we can insert anywhere, but in stack this is the restriction. At least it will have only one end. In that end only we can insert and delete. So I am just explaining what is the how it will work when a function is getting called. How it will work internally. That's only I am explaining now. So you will have, usually we will have some stack. So when a function is getting invoked, that function related information so will be allocated with some memory in the stack. And then again in our case again another function will get invoked 4, and again it will invoke another function like factorial of 3. So like this it will keep on get added at the stack. So factorial of 2 will be there, and then factorial of 1. So finally what will happen? Factorial of 1 will return 1. It will not do any computation, it will return 1. So this entry will get deleted and this 1 will come here to this function. So this function will return 2 into 1. So this entry will get deleted and this 2 into 1 value will come here. And this function will return, so 3 into 2, that is 6. So 6 will be written by factorial of 3. And this function will return. So after the function execution, that function later information will be deleted from the stack. And again, here the function will contain 4 into, this function will return 4 into 6. So 24. So this 24 will be returned to this factorial of 5. And again factorial of 5 means 5 into 24. So finally we are getting 120 as answer. So this is how it will happen. So over time, each and every time when a function is getting called, it will be allocated with new memory space. Okay, so it will be allocated with new memory space in the stack. And it will be there until the function is getting returned. So இது வந்து return ஆக ஒவ்வொரு ஃபங்க்ஷனும் வந்து return ஆக it will get deleted from the stack. So there are two parts actually. First, the stack will get filled like factorial of 5, 4, 3, 2, 1. So once it reaches the base condition, it will start returning. So factorial of 1 will return 1. So the factorial of 1 will get deleted. And now at the top we have factorial of 2. So 2 into 1 is 2. That will be returned to the factorial of 3 and the factorial of 2 will be deleted from the memory. So likewise it will happen. So array function தான் கிடையாது. So each time when a function is getting invoked, it will be allocated with separate memory space and it will work executed separately. There is no relation between, because we have used only n here. So initially the value of n is 5. Next time the value of n is 4. So how it will get stored? It will get stored separately only. So in this function, the value of n is 5. In this function, the value of n is 4. Like that, for each value of n, there will be separate memory and it will get executed separately. So see, so here also the same thing. The sequence of recursive calls. So 5 factorial means it will call the statement n into factorial of 4. So factorial of 4 will get invoked. This 4 factorial of 4 will call 4 into 3 factorial. So like that it will go on. And finally 1 factorial will start returning to the previous function call. So this 1 will be returned here and this 2 into 1 will be returned to the previous function call, that is 2, and this 2 into 3 will get, that is 6 will get returned to this previous function call. So 6 into 4, 24 will return here and 24 into 5, finally 120 will be returned to the printer. So this is how the procedure happens. So here one more thing. So in our program, so we have mentioned only the base condition, like if n equal to 1, then return 1, else return. So here one more thing is also there. We have, if it is 0 factorial, what will happen? So in that case, we can write or 0 factorial is also 1. So or n equal to 0, then return 1. Otherwise, go for n star factorial of n minus 1. So or we can here write like this also. Answer equal to, and similarly answer equal to, and finally we can return answer. So like this also we can write. Okay, so we'll see one more example. So sum of natural numbers using recursion. So our input is now maybe they are going to give some number like 5. We have to find the sum of natural numbers, that is 5 plus 4 plus 3 plus 2 plus 1, which is 15. So we have to find this as an output. So how we are going to implement recursion in this? Again, this 5 plus 4 plus 3 plus 2, or 3 plus 2 plus 1 can be written as 5 plus, and this 4 plus 3 plus 2 plus 1. It can be also written like this. That means if you want to find sum of 5 means we can find it using this formula, 5 plus sum of 4. And similarly, sum of 4 can be written as 4 plus sum of 3. And the same thing, sum of 3 equal to 3 plus sum of 2. and sum of 2 equal to 2 plus sum of 1, and finally sum of 1 we can directly return sum of 1 is 1. So in general, how we can write this? Instead of this number, we can write it using n value, that is sum of n equal to n plus sum of n minus 1. That's all. So the same thing, how we are going to write in the form of program means, so define, so sum of n numbers. So the input is only the n value, so n, and then we have two parts, so base part and recursive part. So base part is if n equal to 1, then return 1. Else return n plus sum of n. This is our function name, sum n, sum of and n minus 1. And finally, we can call this statement using the function called sum of 5. If we run this, so I think I didn't get the value and print it. So either I can get it or print, or directly within the print itself, we can call the function. So the value will get printed here. So here we cannot print, actually here the function has to return. Suppose if you are printing like this means what will happen? Return value of each and every function call will be printed. So see here in this case, so in recursive function we have to return the value only. To get the final output we have to return the value. So only to get only the final output we have to return the value. Otherwise all the intermediate results will also get printed. So for example, so see here, I'm running this program. We will return it. Okay, so here the problem is actually okay, where I have to return. Okay, so see here we are getting the intermediate result. So if I am printing in the recursive function, what will happen? The return value of each and every function call will get returned. For example, so இதுல வந்து usually என்ன நடந்திருக்கும் நமக்கு sum n of 5 வந்து would have invoked sum n of 4 and sum n of 3 would have invoked sum n of 2, and this would have invoked some n of 1, and finally the value will get returned. So finally here it will stops. So in that time what will happen? Some n of 1 means it will print the value. It will print the value as 1. So here it will print the value as 1, and then after that this function will get deleted from the stack. This 1 value will go here. Here the value will become 2 plus 1, which is 3. So that's why here we have next 3. This 3 will be returned by this sum n of 2. And again here 3 plus 3 is 6. Again this 3 is printed here. And finally this 6 is coming here. That 4 plus 6, it becomes 10. So this 10 value is printed here. And finally this 10 plus 5 is 15. And so finally the value is 15. So here we have written the print statement in the function. So each and every intermediate results are getting printed here. But we need only the final result, means in that case we no need to write this print statement. So what will happen? Here only I am going to include the final print. So finally this sum of n of 5 answer alone it will print. So otherwise if you are using print statement within the recursive function, each and every intermediate results will be printed by the functions. And then, so this is, then we'll see one more example. So that is Fibonacci series. So we know the Fibonacci series means, so this is the 0th term, first term, and how we will get this term means the sum of previous 2 terms, that is the nth term. So nth term can be calculated by sum of n minus 1 and n minus 2 terms. Similarly, this 2 will be calculated from the sum of 2 previous number, which is 1 and 1. So 1 plus 1, which becomes 2. Similarly, this 1 plus 2 becomes 3. This 2 plus 3 becomes 5. So this is how it will go. So suppose now if we want to find the nth term of Fibonacci series, that is if they have given us 5th term means, so it is 1, this is 0th term, 1, 2, 3, 4, 5. That is, this is the 5th term of the Fibonacci series. So how we are going to find that? So to calculate, to find the 5th term, we have to go for, we have to first find the 4th term and 3rd term. Then only we can find the 5th term. So 5th term means, if we want to find 5th term means, first we have to find 4th term and 3rd term. Similarly, for finding 4th term, we need to find 3rd term and 2nd term. Likewise, 2nd term or 3rd term. For finding 3rd term, we need to find 2nd and 1st. 2nd term and 1st term. And similarly, 2nd term means so 1st term and 0th term. 1st term and 0th term. And here the first term is, so first term usually we will, it's the final one, we will, you can initialize the first term as 1 and 0th term as, because these are the initial condition 0. So this is where the base part of the recursive function comes. So using these conditions only, we have to stop our recursive function. Till that it will recursively call the same functions. Okay. So now how we are going to write this means the same thing, same way. So def pb now c. The input is n value, that is the term, and then first we have to write the base part, and then we have to write the recursive part. So base part means if n equal to 1 or n equal to 0, then what we can do, we can directly return the n itself. That is, if n equal to 1 means we are just going to return 1. Fibonacci 1, we are just going to return 1. And if n equal to 0 means, that is Fibonacci of 0th term is, Fibonacci series in 0th term is 0 only. So 1 means it's going to return 1. 0 means it's going to return 0. That's all. And then our recursive part is else. Same thing. So return. Here we are 2 times going to call the same function from this function itself. So Fibonacci of n minus 1 plus Fibonacci of n minus 2. Like now inside this Fibonacci function itself, we have called the function, the same function 2 times. That's all. And then finally here we can call the function within the print statement, Fibonacci of 5. So here we are getting the 5 as the answer, final answer. So here also if we just printer the intermediate value, we will get the whole series itself. So for example, A equal to Fibonacci of n minus 1 and B equal to Fibonacci of n minus 2. Answer equal to A plus B and print answer, return answer. Here also we can write answer equal to 1. So this will print all the intermediate values for us. So this is our actually the final value. So this for finding the value of 5. Actually 2 times we will not get the exact series because for finding 2 times everything will get invoked, because for finding the Fibonacci of 5, we need Fibonacci of 4 and Fibonacci of 3. And similarly for finding 4, again we need Fibonacci of 3 and Fibonacci of 2. So if you see here means the function will get invoked with the same value at different times. So if you print it means you will not get actually the exact series. It will be 2 times all the function will get invoked. For finding the Fibonacci of 3 also we need again 2 and 1. So like this we will get the output. So that's all about recursive function. So that's all. Whatever you are implementing in recursive function, you can also write it using normal looping statements like while and for. Here the same factorial program you might have implemented using looping statements also. But if you see this programmings, it will look somewhat more easily, you can understand it also. So this code is also very simple instead of using while loop, and you can easily tell, okay, factorial of n means it is just n into factorial of n minus 1. Likewise, recursively we are solving the problem, so code will be somewhat easy, but still there are many disadvantages recursion also. So one thing is, the code will be somewhat complex to understand only, because we will think we have only one function and there is only one n. How it is happening? So that visualizing is somewhat difficult in the case of recursive function only. We have to understand the concept well, and we should be able to visualize, then only it will be easy for us to think. But still, the complex program can be solved using with less number of codes. If you are going for recursive function, then you can solve the complex problem using very less number of codes. But the thing is, it will be somewhat difficult to understand. And if by mistake, if you have forgot to include this base part in your programming, then surely it will result in infinite loop. We cannot tell it as infinite loop. We can tell it's a maximum recursion depth. In Python, we are getting like this. In some other languages, we will get stack overflow, because as I told, each and every function is getting invoked. It will get stored in stack only. After the function returning only, it will get deleted. So what will happen? It will just keep on calling, means the memory will be full, and it will result in a memory error. So we have to be careful while we are using the recursion. And another time is more execution time and more space. So if it is a very simple problem, we can simply go for the normal looping statement itself. If it is a complex problem, then we can go for the recursion. Why means? More execution time. Actually, for finding a function call usually takes some additional time. As I told, during every function call, many steps will happen, like, okay, what all separate memory will be allocated for each function calls, and it will also store where the function has to finally return the value. So such informations will be stored, and the control will go to that particular function and it will execute. So that usually if your program has function, means it will take some additional time only for calling the function and returning the function. In recursive function, what is happening? Even for finding a factorial of 5, some 5 times the same function is getting invoked. So it is actually taking extra time only. For the simple program, it is good if you are using the looping statement itself. But there are some complex problems also. In that case, if you are using the recursive function, your code will be, in that case, even if the function invoke multiple times, it will not make much difference. So in that case, we can go. Otherwise, recursive function will take more execution time and also more memory space compared to that our normal looping type of statements. So I think you can just answer this question. What is the answer for this? Okay. Vedanayaki ma'am, it is B. Yes, thank you. So it's a correct answer. B is the correct answer. So here what will happen? So suppose we'll take some sample values like 30. So we'll take some sample values 30. So what will happen? 30 by 5 will give 6. So first initially n equal to 30. So n is equal to 1 or n is equal to 0. So it does not satisfy this condition. So it will go here. So n mod 5. This will find the remainder. So 30 mod 5. The remainder is 0. So 0 not equal to 0 means this condition fails. So it will go here and it will again call the same function with a different value. So that is 30 divided by 5. Yes, it will become 6. So again the same function will get invoked with the value 6. Now the n value is 6. So now again this condition fails and here 6 mod 5 is 1. The remainder is 1. So 1 not equal to 0 will become true. So it will return 0. So now our input is actually 30. For 30 it returns the value as 0. So similarly, suppose if our input is 25. So in that case what will happen? Here we will have 25. So 25 mod 5 will be 0 only. So this condition will also fail. So finally it will go here. So 25 divided by 5 will become 5. So here again it will call the same function with value 5. So this condition fails. But this condition 5 mod 5 is again it's 0. So 0 not equal to 0. So it will go here. So again here now our n is 5. So 5 divided by 5 is equal to 1. So here again the function will get invoked with value 1. So this condition will satisfy. N equal to 1 means it will return n. That is it will return 1. So for 25 it is returning 1. For 30 it is returning 0. So this 25 is actually a power of 5. Otherwise it is returning 0. 30 is a multiple of 5 only, but still it is returning 0 only. So only for power of 5 it is returning 1. For other things, so here we have to work out and see only. We cannot just simply do this. So it will be confusing. So we have to just work out and see. Answer is B. And what about this? Okay, it's not. Okay, we'll just solve this. Function of, initially our value is 513 comma 2. So what will happen? N is greater, our n value. So this is our n value and this is our r value. Our n value is greater than 0 only. So we can go for the recursive part. So function of 513 comma 2. So it will be, again it will return n mod r, that is 513 mod 513 mod 2, which is 1 only, because the remainder will be 1. So 1 plus, again we are calling the same function, n divided by r. So in Python we will usually for integer division will go for double slash. So 513 divided by 2 we will get 256 256 comma r is the same thing 2, and then again it will, the same thing will happen, function 256 comma 2. So again here 256 mod 2 is 0. Okay, so 0 plus, again the same thing, function 256 divided by 2 is 128 comma 2. So likewise it will goes on, and what will happen here, again it will become 128 divided by 2 is 0 plus that function of 64 comma 2. Again this will become 0 plus function of 32 comma 2, and then again 0, because these are just multiples of 2 only, so we will get the remainder as 0. So 0 plus function of 16 comma 2, and again 0 plus function of 8 comma 2, 0 plus function of 4 comma 2, 0 plus function of 2 comma 2, then 0 plus function of 1 comma 2, and then again 0 plus function of 0 comma 2, 0 plus function of, sorry, now n mod r, now our n value is 1. So here our n value is 1. Till now, till this, the n is just a multiple of 2, so we get the remainder as 0. This n mod r value remains 0. But here now the n value is 1. So 1 mod 2 will become 1. Okay, so finally again we are getting again ஒரு 1 plus அப்படிங்க வாங்குது. So initially ஒரு 1 இருந்தது. So this 1 plus 1 will become 2. So our answer is 2. So initially when the 513 is there, we got one remainder as 1. Then after that it all just a multiple of 2. So all the other answers are just a 0. And finally we got n value as 1. So this 1 mod 2 is also a value as 1. So finally on adding these two ones, we are getting the answer as, write it out and then only we can find it. So the last one. So here function of 5. If n is equal to 0, return 0, but it is not. So we are, yes, it's D answer. But here one thing, inside the recursive function itself, there is one print statement. So it's not simply returning any value, but instead of that, it is printing. So what will happen? So it will 5 divided by 2 means we will get 2. And then again, function of 2 divided by 2 we will get 1. And then again, 1 divided by 2 we will get 0. So now this is 0. So n equal to 0 means this will return 0. So 0 only. But here, after here in this function n equal to 1, so what will happen? Now your control will come back here. So the function of 0 return ஆன உடனே இந்த control இந்த இடத்துக்கு வந்துரும். It will come here. So again what will happen? It will execute this statement. So now the n value is actually 1. So 1 mod 2 is 1. So it will print 1. Then again it will come back here. So in the call முடிஞ்ச உடனே it will come to this print statement. So 2. Now actually the n value is 2. So 2 mod 2 is 0. So 1, 0, and finally return here. So 5. 5 mod 2 is 1. So our answer is 1, 0, 1. So in the previous cases la நம்ம டைரக்டா ரிட்டர்ன் போட்டுறணும். இந்த print statementum போடல. So உங்களுக்கு ப்ராப்ளம் இல்ல. பட் now என்ன இருக்கும்? So for example, ஒரு function 5 call ஆகுதுன்னா இந்த ஃபங்க்ஷனுக்குள்ள we would have call like function of 4. அடுத்த statement actually print னு ஒரு statement இருக்கு. Print 4 இல்ல n 5 தான் இல்லையா? So 5 mod 2. And then here again function of 4. So here function of 4 divided by 2 is 2. Again here we have one more print function where n value is 4 only. So 4 mod 2. And then again here function of 2. So here function of 2 divided by 2 is 1. And then here again we have print 2 mod 2. 2 mod 2. And then again function of 1. So function of 1 divided by 2 is 0. And here print 1 mod 2. And then finally function of 0. So function of 0 will return 0. So it's not going to print anything, it will return 0. So after this function execution, the control will, so இதுல இருந்து தான் இங்க கால் ஆயிருக்கு. So actually the function 4 ல இருந்து it came to this statement. After this function call it came to this statement. After this function call it came to this statement. Now while returning, after this function execution, this is returned to the next statement. Usually in previously we wrote some programs, we don't have any other statements, so it will return and finally it will print the final value. So here it's printing some intermediate values also. So it is returning here. So this print statement will get executed. So what is 1 mod 2? It is answer is 1. So initially this 1 will get printed. So 1, here 1 is getting printed. After this function execution, again the control goes here. So it will execute this print statement. So 2 mod 2 is 0. So it will print 0. And then again this function 1 will return here. Sorry, this function 2 will return here, and then this print statement will get executed, and likewise it will goes. So ஒரு function recursive function call நடந்ததுக்கு அப்புறம் அந்த function வந்து next statementல இருந்து it will start its execution. So that is the case. So any doubts in this? If you have any doubts, you can ask, or we can go for the lab sessions.